get started here because you are the main event, and I just want to take a minute here for an introduction. You should be seeing a slide, MedVR Accelerator and Bootcamp. We spun out of the MIT Media Lab doing innovation in XR and got focused on how you produce prototypes and products. And one of the most interesting areas to work in is in medical XR. Later this year, we're going to open up an accelerator in the Longwood Medical Center in Boston. The reason for that is that the clinicians and scientists play such an important role in being the expert users, the domain experts, which we're going to talk about a lot today, because we have two domain experts who also write code. But if you're going to have them involved in projects on the long term, you've got to be right close to them. On that note, the idea for this talk actually came from some XR innovation work I did at USC in 2017 and 2018, and I was working with a postdoc in the bioengineering school, Winston Tran. And we found it very, very easy to track down people in engineering, in games, in literature, in journalism who are interested in XR. But it was really hard to find people in the medical school and in bioengineering. And the problem is they are super competent. And they do it on their own. They don't come out to meet, so there's no record of them. But people in those fields start with such wonderful STEM backgrounds that they can contribute both as domain specialists and domain experts, and also as prototypers. One note just before we get started, there's a Q&A section. We'll probably be able to answer a few questions at the end. If you have questions, please add them in the Q&A. I'm going to introduce our moderator, Bernard François, interesting person to moderate this talk. We have two doctors that are very competent software developers, and Bernard François comes from one of the areas where you find some of the most competent people, which is in prototyping. His firm, PreviewLabs, is entirely dedicated to helping other organizations figure out what their applications should be, whether it should be on multiple platforms. He comes from a strong game background, which makes things even more interesting. So with that, I'm going to turn things over to Bernard and get this started. And again, don't forget the Q&A at the bottom. We'll probably be able to get a couple of questions answered at the end.
That sounds very good. Thank you so much, Steve. It's a pleasure. I will first quickly show a little bit of PreviewLabs as giving it a little bit of context, and then I'll show a bit of the process of prototyping, and then we'll see how Omar and Joe apply this in their fields as well. So I'll just quickly start by sharing. There we go. So this is just a short video, just showing a little bit of how game technology actually has a lot of different applications. For example, this is a prototype we did with Michigan Medicine for distraction while driving, like to kind of educate people about this. We've also done one about dating. and STI testing and such. So there's prototypes that are in VR, some are multiplayer. This is a language learning game, like to practice early reading skills. So there's a lot of different applications basically that you can create. And as you can see, prototypes, they don't always look like finished games. So that's it's actually by using some kind of more functional graphics, you can actually get already pretty far in kind of getting an idea of a concept when prototyping. One of the kind of images that people frequently use when talking about prototyping is kind of what they call the idea funnel, where basically it's like this funnel where at the top you start with a lot of ideas. Like there's a lot of things you can do. Let's say maybe you're a doctor and you want to come up with some way to help people and through software, but there's a lot of different things you could do. And the question is, where do you start? So of course you start by generating a lot of ideas, maybe not going for the first idea right away. So you can do that through brainstorm sessions. You can then think about these concepts and select them, and then you can start prototyping. So by keeping it very rudimentary in the beginning, we actually help our clients to explore different concepts and see what has a higher potential before kind of committing to something, and then you can kind of develop it a little further. And of course, so basically, maybe in general, you could say you start small. And that's how a lot of ideas start. And I'm very curious to learn more about the work of Joe and Omar, how they apply this. So I'll now proceed with a quick introduction. First, I'll stop sharing my screen. There you go. So first, we have Dr. Joe Morgan. So he's an anesthesiologist, and he focuses on patient-centered applications using extended reality within healthcare. So including in pediatrics, senior care, rehabilitation, including for applications where you want to reduce discomfort during anesthetic procedures with local anesthesia. And then on the other hand, we have Dr. Omar Aly. He's a colorectal surgeon, and his interest in video games and software development actually started really early, like inspired from video games. He wanted to kind of get into software development as a teenager, but then later went into medicine, became a surgeon, and then is still working on kind of integrating these two passions, medicine and software development, to integrate them and give them a place. So yeah, I would say take it away. We can start with Joe. You have a small presentation first.
Yeah, so I'll share my screen here. Just let me know if you give me a thumbs up. You can see it. Okay, great. So thank you, everyone. I see I kind of peeked at the attendees, so I see a lot of friends and colleagues that I've met over the last almost going on 7 years now. So excited to be chatting with everyone and for the opportunity. I'll just dive right into it. I know the theme today is, doctors who code. And I'll just give a few slides and then a video of what we do. The company I founded is called Why Health. I founded that company 6 years ago. And these slides, again, they focus on what we do and why we do it. So with that, I'll just move forward. So the genesis and the motivation behind our company is that healthcare today is very much like a big hippopotamus. And what I mean by that is it's big. Most of the time it's very slow. And if you know the statistics about the deadliest animal in continental Africa, it's a hippopotamus. And so technology in healthcare, we all know as practicing providers, situations where technology falls far short of what's possible and really what's common practice in every other industry with regards to utilization of technology, and having that what's possible be much closer to what is actually done in reality. And there's just such a huge divide within healthcare. It's very frustrating. And that was kind of the beginning motivation of like, what can we do to actually get that what's possible closer to reality within technology? And there are several reasons for that divide. One is that, there's this move fast and break stuff mentality within tech. And of course, in healthcare, it's the polar opposite, do no harm as the fundamental construct. And as providers, we have a constant need to basically do more with less, and that's probably not going to change anytime soon. And so extended reality quickly became an answer for us shortly after the inception of the company, because of its characteristics to achieve engagement, to control the spectrum of attention, whether that's complete distraction all the way up to we're going to remove distractions in our busy, noisy world and really have you focus on what's in front of you, whether that's an assessment, a treatment construct, or some other capability. Obviously, immersiveness is a big quality, and because it's digital, it scales with minimal cost. Why is XR very useful in pretty much any medical specialty? Well, because the brain is a very potent medium, and we are largely audio-visual mammals, and so this is a nice illustrative paper, and it's, without going into esoteric details, the point is that they basically compared patients that were in an extended reality experience, virtual reality in this case, with the EEG signatures of patients that were actually on LSD, and they could not decipher between those that were in virtual reality and those that were in that were on LSD. And so the point here is very simple. This is a very potent medium, and it needs to be respected, certainly in a healthcare context. Just some quotes. I won't stay on this slide for too long, but what we've built and what we've done is very effective. It works, and it's kind of we've heard a lot of those themes over the past 6 years. We are a company with a national presence. We're in over 80 hospitals and growing. Just some overall summative statistics here. I have a video, but I'm actually going to open a separate window here because I found that, so I'm going to stop sharing for just a moment and switch over because I found that when you try to watch a video within PowerPoint, it always fails. So I'm just going to show this video. It's about a minute long, and then I will wrap up and pass over to Omar. And so that is, in a nutshell, the broad scope of what we do at Waya Health. And just in closing, and I think this kind of brings us back to the theme of today. I think the main thing is that, and this is really, I'm speaking to the providers and the developers in attendance today. And this is the key point, and this is the epiphany that I had years ago that I think just becomes reinforced in my mind as we go forward. And that extended reality is not, a simple game. It's a medium, and it's a medium that can be used in a healthcare context as a diagnostic lab, a pharmacy, an enabler of the next generation of telehealth, and it can also perform a lot of automatable tasks that kind of are not the central focus of healthcare, which is of course the interaction between patient and provider. And so, you know, that in terms of a long-term vision is certainly you know, what we're doing and what we're working on every day. And so with that, I will pass it back to Bernard.
Awesome, thank you. So now we go back to Dr. Omar Aly for his introduction.
Thank you, Bernard and Steve, for having me. I'll just open up my presentation.
So meanwhile,
you guys see my screen?
Yes, perfect.
All right. So basically, as Bernard was saying, this passion of mine started in my teenage years, and I was basically interested in knowing how things work under the hood, whether that was video games or human beings. And I've gone into a medical career and I've become a surgeon, but that passion of knowing how things work and tinkering around is what's brought me here today. So essentially what's inspired me to work on a surgical simulator prototype is how surgical training currently works. Basically, at the moment, we've got this old mantra where you see one case, you do it under supervision, then the next time you're probably teaching it. It's probably not as extreme as that, but we are under a lot of pressure, especially with the pandemic, and dedicated training time has become a precious commodity. So I think this statement by the Royal College of Surgeons really emphasizes that we need to go into technology-based training. We can't train with that old model of seeing something once, then doing it, then teaching it. You have to practice in a safe, controlled environment. So just a quick summary for people who don't know what GI surgery entails, gut surgery. So basically we have multiple modalities that we can operate on the gut. We can either do open surgery through big cuts, keyhole surgery where we use instruments with 5 degrees of motion and a screen, or we have robotic surgery where we digitize the inputs through a controller, which actually looks a lot like a VR controller, and that is translated to motorized instruments. What's inspired me to develop my own simulator was the current disappointing landscape of surgical simulation. At the moment, what's quite popular because it's cheap is low fidelity simulation, where you make a shoebox and you put some instruments in and you stack some sugar cubes. It's good to get the basic motor skills, but it gets very boring very quickly. You've got very expensive high fidelity simulators that are usually in big university centers, but they're mostly for the research setting. The trainees and the residents don't get a lot of time on them because they're quite costly and sometimes use a lot of single-use consumables like plastic models, silicone models. Or we have cadaveric tissue, which has a lot of ethical problems and accessibility problems. So my personal approach is I'm a surgeon, my hands are a surgeon, my mind thinks as a programmer, and my passion lies in video gaming. So I think VR is an excellent medium, like Joe was saying, a tool that we can use for healthcare. So my aims were to leverage the input devices that we get with VR to develop a surgical simulator. And I wanted to cover all of those modalities. And I think the only way to do that is to simulate surgery from its basic fundamentals. So the features I wanted to simulate was the behavior of soft tissue, the correct tissue response to how we manipulate it, how the instruments handle, and sort of try and simulate some biological phenomenon as well that I haven't seen done by other people, like blood flow through the organs, how electrocautery reacts to the organs, etc. So here's an example of the prototype compared to real surgery. So here we're removing a gallbladder using keyhole or laparoscopic surgery. And here is a view from the laparoscope. And on the right-hand side is a VR view. And as you can see, we're sort of retracting the gallbladder, applying the electrocautery instruments. And it's basically teaching the same motor principles of using both hands, trying to have 3D perception with a 2D screen, because ultimately, even in VR, you're looking at a 2D monitor that's simulated. And then another prototype was another simple operation, which is removing the appendix here in keyhole. And then here in open surgery, removing the bowel, removing the appendix, and just showing that the same principles that I'm trying to simulate with a soft tissue simulation are essential for actual surgery. And then some additional features like blood flow. And here we can see the blood coursing to the organs, and then it reacts realistically to cutting, to cautery. So you can deal with complications. You can make mistakes in the simulator, just like a pilot within in a flight simulator. It's not a sort of a restricted environment. It's more of a sandbox where you can experiment, play around, and learn from your mistakes safely without harming the patients. And I think by doing this sort of high fidelity simulation, you're not going beyond just remembering the key steps of the procedure. You're actually understanding them, applying them, and putting them into use into new scenarios that are a lot more dynamic and engaging than the simple simulators that are made out of few boxes. Obviously, I've extended this simulation work for research as well. So coding's been very useful for research, and I've been using it to maybe prototype and improve the operations that we do. So instead of experimenting on patients with clinical trials, we can prototype our operations on the simulated model before we expose patients to harm. I'll hand that over to you again.
Okay, that is really interesting and fascinating to see the examples, and it's always cool to see it in action, which I personally like a lot about software development and using game technology. It's such a visual medium, so it's very satisfying to play with and interact with, but also to build it. So it's at some point I discovered for myself that making games is actually more fun than playing them, or at least to me. And I guess we're all in the same boat with that. So first question that I have is kind of going back to the title of our talk today, Doctors Who Code. Stephen actually said earlier, also in our previous meeting, like typically doctors don't code because they don't have time for coding, or you're supposed to not have time, right? Or that's what people think. So how much time do you have for coding, and how do you integrate that with your profession, and like, are you working part-time and then coding part-time? In which context? Like, do you there's Waya Health, I don't know, Omar, if you have your own company as well, and so then also to which extent you have to work with outside parties if you don't have enough time, or like, can you tell me a bit more about that? Like, so basically how you fit that in your busy schedule, and how that maybe forces you to work with other people. Maybe Joe, if you can go first.
Sure. Yeah. So that's a really great question. And the answer is a couple of things. The first is that I still do practice clinically, and I think it's important to do so, simply because keeping that notion that I'm here because when I'm working at the hospital, or whether I'm developing these applications, the point is to help patients. And so not getting too far removed from that, I think, is absolutely critical. There's been a lot of times where what I'm doing in a development sense is actually greatly hastened just by simple knowledge of how things work within a healthcare context. And so it allows for certain efficiencies on the development side, and then also I think it pays dividends in a reciprocal manner, where I think there are certain insights that are gleaned from the work developing extended reality applications that pay dividends in terms of just better patient care, and not even necessarily in the context of using extended reality, but just the insights that are gained through that process of iteration and getting feedback and listening to patients about what their issues are, and so forth. And in terms of the question of balancing time, My solution has been very simple, but it's worked out. And it's basically, I have three things that I do other than sleep, and that is, clinical anesthesia, Wyatt Health, and I spend time with my family. And that's been the case really for at least the past 5 years. My social life is largely limited to interactions with people I very much enjoy spending time with, namely those that are in extended reality for healthcare. But it's very true in that if you do what you love, you don't really feel like you're working. And I feel very lucky that I can say that and really mean it.
Awesome. So, okay, Omar, tell us also a little bit more about like how do you integrate your coding practice with your medical profession?
So I'll answer your first question as well of why don't a lot of doctors code, and I think it's to do with how our education system and high schools are set up before entry into undergraduate education, because you're sort of funneled into certain subjects, and I think a lot of doctors will have to study biology, chemistry, physics, but then they'd miss out on learning the technology skills. So I think that's probably why a lot of them never acquire the skill, because they're never exposed to it, and maybe they're forced to learn it against their wishes when they're having to do research as part of their clinical practice. So I think they're sort of deprived of that precious gift or tool that I think the future everyone should be able to do, just like how people use word processors, etc., on a daily basis. How I balance the time, I actually find coding is a very flexible hobby. It's you can do it at any time. We work unsociable hours, but you don't have to do coding socially. You don't have to attend sporting events that are at specific times that you'll always miss because you're operating or you're doing your own calls. So you can do it at any time you're free in the middle of the night. And it's an international community that you can learn and collaborate with. So there's always someone to talk to at any time and collaborate with. So it's actually a very flexible hobby for a doctor, I think, compared to in-person hobbies.
Yeah. And I have to say, I'm pretty impressed by the examples that the two of you have produced and shown here. Like on one hand, Joe having a large array of activities that you can do in VR, and then Omar with your physics simulation. I actually think it looks really good, like, because these are kind of challenging things, like I mean, either way, like coming up with all the different things and then or going more deep into the physics simulation. Do you both like, do you do everything yourself, or do you have other people? It seems like you, Omar, you call it a hobby. Joe, you have like it's a company. Is that also how it's actually structured? And then do you have other people that actually do the coding? How does that work?
Is that for me or Omar?
Yeah,
Sorry.
both. Yeah, for both of you. Like, do you each seek help and to get enough work done, or do you just do it at whatever pace you're able to do this? Or
Yeah, so at Wyatt Health we have 7 full-time employees. So we're a company, and we started out with just independent contractors a long time ago. And when we first started, I had done a little bit of scripting, but I was very much a novice. And now, 2 of our 7 full-time employees are formal software engineers with, computer science degrees and very, very accomplished and skilled programmers. And so one of them has been with us for a while, and he's been kind of a mentor to me on the coding side. And I think that's just a great bit of advice for everyone who's potentially interested in getting into it, is have a mentor. And really it's something, particularly in extended reality where there's a ton of resources out there. And like for Unity, for example, and that answers one of the questions I saw in the chat, which is we use Unity primarily as our game engine. And there's just a ton of resources available to learn how to use the game engine and also how to program. And it's a very gratifying way, as we kind of alluded to earlier, in terms of learning how to program, because you know, you have a visual result that you can appreciate almost immediately. And so that really eliminates a level of abstraction that would normally be, I guess, if you're, you know, using the command line or just, you know, purely, you know, having no visual output, I guess. So that is, you know, that is the long and short of our company, and just a little bit about how I got into it. And so, you know, over time, what happened was I was the previous scripting I had done was in Python, so I had a little bit of background Python knowledge, and you know, Unity is obviously C#, and so you know, my language is really focused on C# and Unity, or Unity, C# and Python. And Python is really useful for, you know, general tasks, particularly things that are rote that otherwise can easily be automated. You can quickly script something that takes care of a lot of rote tasks, and then of course artificial intelligence and using AI to do all sorts of different things. And just a little bit about that. 30 seconds. It's really important for people to understand that AI is, like, extended reality would not be around without AI, particularly computer vision. So if computer vision didn't exist, the modern day headset would not exist, because it's utterly reliant on computer vision to figure out where it is in three-dimensional space. And you know, that is, as everyone knows, that is, you know, fundamental to be able to, you know, deliver virtual reality, certainly in a way that won't cause you to be nauseous after 5 seconds. So just a little aside about that. And I think, you know, one point to touch upon perhaps later in the conversation is the emergence of traditional programming code, extended reality, and artificial intelligence, because I think the writing's on the wall, and you know, it's certainly going to be a central part of everything that we're doing within this budding industry over the next 5 to 10 years.
Yeah. So yeah, like for me, like, having been running this prototyping company, we have definitely seen, like, well, we've used a lot of Unity for our own prototypes, and in the last 2 years we've actually also seen really an uptick in other engines as well. Like, people are kind of exploring different avenues. I mean, in the beginning of VR, there were people coming in with Unreal, because coming more from a VFX kind of perspective, they kind of gravitated towards that. That was in the very beginning, companies doing 360 video content and then kind of turning it more interactive from that angle. But now there's also a lot of people from the game development community that are more and more kind of trying Unreal as well, and so this kind of becoming more of a mix. So Omar, what is the technology you use? Do you use Unity or Unreal, perhaps?
So the technology I use is probably what I'd advise against using for people that are trying to get into this, but I've just used it because it's what I'm comfortable with and what I've been using for a while. So I've built this on C++, and you're asking about what sort of disciplines I've been doing. So I've done the code in C++, the code for the shaders and the rendering, the code for the GPU simulation in OpenCL, and the art as well. I'm not a very good artist, but you can't really get good anatomical models that you can prototype with, so I had to do the art myself. So basically it takes a lot of man hours, and I had a look at your website, and it's quite interesting how many man hours each project takes. And I guess if you're trying to do everything yourself and you're not a master of each discipline, it probably takes 10 times longer. So the reason I chose these technologies is that doing something like this, a soft tissue physics simulation, it requires really high performance. So I'm simulating about 20,000 simulation elements, which are sort of pyramidal elements at less than 10 milliseconds. That's the manipulation, the collision detection, the bleeding, etc. So it's choosing the right technology for the application you want. So if I in retrospect, I think this my methodology is probably overkill and not very friendly for a lot of AR projects and VR projects. So I'd advise against it, but that's what I've used.
Yeah, I can definitely imagine it. It's a really interesting learning journey that way. Kind of you get to know the ins and outs, because yeah, it seems like you started from the ground up.
Yeah, I started in the early 2000s, so
yeah,
we didn't have all these luxuries.
Yeah, and then other people like Joe started kind of from top, as in yeah, from the very visual side right away. So it's like if you started in C++, you start with kind of nothing, and you're hoping that it will compile and that you'll get to see something on the screen. And just out of technical curiosity, like you starting in C++, like did you use any specific libraries? Like, did you target a specific platform? Did you say, okay, are you coding directly against OpenGL, like directly with the hardware, or do you use any libraries there to kind of make it a little bit easier?
I use Steam VR for the VR API, and then I use a rendering only engine, so it's not a game engine that I'm used to using. So the reason I chose it is just because I'm used to it. So it just hastens the prototyping phase. It's called the early extend, and it's open source, so I can modify it and adapt it to my needs. But if I'm thinking about a full-blown product, I'll probably look at something that already is bug tested on a lot of VR hardware, a lot of mobile devices, and switch to that.
Yeah. So are you running your, because you say performance is important, and I do understand for the simulation, if you're simulating a lot of like, yeah, individual elements of which a larger object is composed at, and the more granular, the better. But are you also focusing specifically on, and maybe this is a question for both, like what VR devices are you focusing on? Is everything tethered to a computer so you have the full computing power of a computer, or are you also using devices such as the Oculus Quest or the Meta Quest 2, but then in a standalone mode with its own kind of mobile computing power?
So for my application, I don't have access to a Quest 2, but for my application, I'm using a tethered device, running multi-threaded code on the CPU and then OpenCL on the GPU. I guess if I have to translate it to a mobile device, I'll have to look into converting that to something like compute shaders that are available on the Quest devices. So I guess that sort of limits your user set. So I guess if you want to distribute something to a lot of patients, I think the mobile devices are excellent, but maybe in a more bespoke simulation setup, a computer wouldn't be a huge detriment if it enhances the fidelity.
Yeah, and so on our end, we're device agnostic, so we really have went to great lengths to ensure that it works on most headsets. Our workhorse is the Pico. We found that they're very easy to work with, and there are some, it depends on the other potential hardware company. They all have different nuances. We had deployed originally using tethered. Our software still operates on tethered, but really for all practical purposes, we switched to standalone as soon as possible, simply because of the setting and the context in which it's being used. And I think that's a really critical point that perhaps is worth further discussion is, the clinical context and the scenario in which you're utilizing something is absolutely critical for making some of these high-level decisions that ultimately save a lot of time and money and get things to the patient faster. So, like for example, in Omar's case, if it's a simulation context, I mean, every hospital has a simulation center or a little simulation room, and so it's okay. It's actually probably advantageous for the reasons he's touching upon, which are, high graphical fidelity and, low latency and so forth, to get as close to a real simulation as possible. That's fine within a simulation context because, anchored equipment is not a problem. They're used to that, and the infrastructure is already set up for it. Oppositely, if you're talking about, utilizing virtual reality for a particular clinical use case where, maybe perhaps the patients are going through a workflow where they're not in one location at all for any significant length of time, like for example, a perioperative context, standalone headsets are really going to be kind of mandatory. So, just a little bit about that, because I think that's really important. And that's a sort of high level decision that if you make a priori with a little bit of planning, you net a huge time savings.
So that's really interesting, kind of this difference, like how the standalone device is kind of really convenient way to work with actual patients, while if a surgeon is practicing, it kind of doesn't matter. It's more about getting the really high fidelity, and that's kind of that kind of works well with the technology choice that both of you made, like as in starting with the Unity game engine and being able to kind of get started kind of right away. While if you work with C++, you can really optimize and kind of create like a sports car of a VR prototype where technically everything is kind of really top notch under the hood. As you actually said, it's one of your interests to make sure to understand what goes on under the hood. So it's kind of interesting how these.
That's the fun part. Yeah.
How these things.
I'm not doing it to make money.
Yeah, it's kind of cool how these things all come together, and I'm pretty sure it's a great learning. Let's see, for next question, I was thinking to go a bit in terms of the journey of developing a product. You're starting with the ideation, and then you're developing and then testing with users, learning, adjusting your concept, and then at the end you bring it to the market. So let's start at the beginning of that journey. So in the beginning, I see, Omar, you're in a very specific niche or a very specific thing that you're working on, while Joe has like a very broad kind of approach, maybe not as deep, but then a lot of different applications. So, so for Omar, how did you select what to work on?
Okay.
And then also for this, after that, same for Joe. Like you have a lot of different applications. Like, do you do any brainstorming to come up with a lot of options? And so, how did you select the different things that you've been building?
So just quickly share. Do you see my?
It says it started screen sharing.
I've just got a.
It's a black screen, but it says you're sharing.
I guess you're selecting a window at the moment.
Is it working?
Not yet.
Not yet. Okay, I'll stop sharing.
So yeah, how did you? I don't know if you want to give it another try.
Okay.
Yep.
So basically, I'll just talk about it. So basically, my process is sort of a less lean version of what you've described, Bernard, because obviously that's your specialty, to be sort of lean prototyping. My process was to brainstorm the features that I wanted as a surgeon that I didn't see in the existing simulators. And then I correlated the features with existing technologies on the market. So I had a look at game physics engines, which are very good at rigid bodies, but not very good at soft tissue. So I guess if I'm maybe doing an orthopedic simulation with bones, and the off-the-shelf technology would fit, but there's no really good off-the-shelf technology that would enable sort of dynamically cutting soft bodies. So that meant that I spent a lot of time trying to force an off-the-shelf solution to do something that it can't do. So that's a lesson learned. So I had to learn how to do soft tissue simulation. And then once I've got that running in an unoptimized fashion and it's stable, then I sort of did some internal testing, looked to see if I can get the instruments to work, get the VR inputs to work. And then before proceeding any further, I made sure that all the instruments I wanted are working. Then I started to optimize the performance. So I think the lesson here is don't do premature optimization. And then finally, because I wanted to do several operations, I decided to make a tool set to making new operations easier. And then finally added the visual polish. So my process is sort of aiming at making a prototype, looking at the existing VR simulation companies. They're sort of the same size as normal game development companies, hundreds of employees. So I think transitioning to a full product requires orders of magnitudes more manpower and expertise. But my objective was to get the features I wanted working in a minimum prototype. And the way I did it is looking at the existing technology, being disappointed, and then figuring it out on how to do it myself. And that's the enjoyable part of the journey.
Yeah, I definitely agree. Like in the beginning, yeah, getting something up and running can be like a small fraction of the whole development cost. Let's say if you were to build something into a product, but it's also the most fun part. So it goes the fastest. Like you start from nothing and you're accelerating and you see the features coming up. And then of course, if that pace kind of gets slower, and it has to as you're kind of making it more stable and everything, and you're not just breaking things and building, and so I definitely agree that that's really yeah, that's pretty exciting, and that's what we were all leveraging. If you don't have a lot of time, or if you're a prototyping company, we're kind of leveraging that thing. Like if you start from scratch, it actually goes pretty fast, and we don't have to worry about scalability and everything as much. So Joe, like the same question for you. Like, how do you select which concepts to go with? How did you gravitate towards maybe some of the choices that you've made in the past? Like, is that a process that evolve over time, or what do you do to determine what to do?
Yeah, so part of that is a manifestation of really a intentional path that we took starting years ago, and that was to identify the characteristics of extended reality that are somewhat novel, that can be leveraged to essentially achieve a result that is beyond that which a two-dimensional medium can provide. And so some of those things I touched on earlier, things like controlling one spectrum of attention, whether that's complete distraction or pay attention only this, and the medium also has some very strong motivational characteristics. And most providers will tell you that patient adherence or compliance is always a challenge, and so any way that you can boost that and boost that engagement, that's going to be beneficial. And so from those constructs and our fundamental capabilities and understanding, what we did was we then looked to, okay, what is the 3 to 4 plus decades of literature in this space already say in terms of what works, what doesn't, and then from there we identified use cases and essentially took the ones that we thought were the shortest path to something that was something that could be helpful. And then, once we identified those, and I think this is a really key point, is let's just say we had a basic experience design, okay? And once we have that basic experience design that's focused on a patient-reported outcome, then everything outside of that, you really have to constantly remind yourself, as well as your team, that everything outside of that sphere of what you're trying to do is ancillary. And it's super tempting within extended reality to just add some extra stuff, like super tempting, right? Because it's a three-dimensional medium, there's a lot of assets available, and it's really something that is a temptation that should largely be avoided. I saw a paper the other day, and it was focused on some medical application, and for some reason there was an element of like, you can do this within your custom city, and it was like, well, what does the city have to do? Like, it was just kind of like superfluous. And so I think that particularly in a clinical context, there's two pitfalls of that. Number one is confounders, in terms of, you go, let's just say you try to show some level of effectiveness of that, then you basically come back and someone would say, well, how do you know it wasn't the city and not what you were trying to do in that example? And then the other thing is, with superfluous additions to experiences, you can kind of get into this situation where you're risking potential patient harm, frankly. If somebody's afraid of cityscapes, that might be a big problem, just as a straightforward example. So you're eliminating potential for harm or mitigating, and then you're mitigating potential for confounders by keeping it simple and focused on the patient-reported outcome.
That sounds really great. So after you're developing, so we're talking about kind of the ideation phase and how to choose which kind of stick to the features or which features to go with, or how that gets inspired. So once you've built something, of course, you want to show it to some patients. Do you feel that's easy to do? Like, can you regulatorily, can you like just show it to people and kind of in an informal way? I know, like if you're doing real academic research, it's pretty strict or kind of formalized, and I guess it has to be, so you can compare results and okay, they use this and this method. How does that work for you? Like, because if I understand it correctly, you're not necessarily academic researchers, but you have your profession, and from your profession you come up with ideas how to help people. So what does that look like, this process of kind of getting it in front of the users? Is that easy to do? Can you easily find some people to test it with? Can you even just roll it out in your own practice? Is that something you're allowed to do as a doctor? How does that work?
Yeah, so that's a great question. I saw a few questions related to that in the chat. So in terms of regulatory frameworks, I can't speak in depth about anything outside of the United States. But basically the way that the FDA has broken down really any digital health implementation doesn't necessarily mean extended reality. There's three categories, and the first one is essentially things that are not under the purview or not under the realm of what the FDA regulates. It's exempt in so many words. Things like nutrition apps, or even distraction by many opinions falls within that category. Then there's class 3 or bucket 3, let's just say category 3, that is, these things are definitely under the purview of the FDA, and they are regulated, and you do need to go through a clearance process, whether that's 510K or a de novo application. And then there is the middle realm, which is essentially items that may fall under their purview, but they intend to use enforcement discretion on. And that is a broad category. And so the approach we've taken is we engage with an FDA consultant, who's been with us now for 3 years about. And so we've gotten professional guidance on that, and then we've also in terms of separately, in terms of like what you're referring to in terms of like how do you try it the first time and those sorts of questions, because I think that's really an important thing. And we don't overcomplicate that. I mean, ultimately, everyone is a patient at some point, whether you're a provider or not, right? And so the first use of something is, as somebody who makes these things, it's usually me, right? I'm putting it out, it's design and rapid prototyping before it gets used on anyone else, and I'm making sure it works as intended, and then the first try on someone else is usually somebody who's around, not necessarily in a clinical context, because and I think it's important to keep in mind that what is the primary motivation? I mean, the primary motivation is to help patients and in a company context make a living doing it. And I think a lot of times, and I think this is a direct statement to a lot of my provider colleagues out there, I think it's increasingly becoming something that's less taboo in terms of being a doctorpreneur. I remember when I was an aspiring medical student, like an undergrad trying to get into medical school, it was really kind of poo-pooed. you know, I've really watched that change dramatically. And I'm a strong supporter of people that maybe outside of the realm of academia want to, you know, basically push the envelope in terms of what is possible to help patients, right? In a way that is compatible with the oath that we've all taken. And so, you know, and ultimately it's like one of these things where, you know, no one can define it, but everyone knows it when they see it, in that, like, if you genuinely care, then you'll back that up with your actions, with your effort, with your time. And, you know, there's, I mean, somebody who gets paid to take care of patients is called, you know, a provider. So it's, I think those lines are blurring in the sense that in terms of traditional casts, if you will, of what this person can and can't do, and not from a, what I'm talking about is in terms of just the technology has enabled us to help patients in a way where somebody who is able to program or develop these experiences can all of a sudden have an impact that extends far beyond a one-on-one interaction. And I would even argue that, you know, part of the oath is really to not just, you know, do no harm. There's more to it than that. And I believe that part of it is really, you know, whether it's research, whether it's, you know, doing something in a technological space, I think that there really is something, and it's really important and core to being a provider of, you know, trying to advance the care itself. And so whatever that is, I think, you know, that's an important thing.
So that's interesting how, yeah, if you're a doctor who codes, you can, it's kind of a powerful tool, and you can kind of, yeah, it's a new way of helping. So Omar, I also have a similar question for you, because it was kind of interesting to hear from Joe, like how there's like 3 different categories, and kind of how that kind of goes with a different level of scrutiny. What does that look like in the UK?
So I think it comes down to what you're using XR as a medium for. If you're using it as a treatment, it comes under a lot of scrutiny. And as Joe was saying, healthcare is very slow. You have to provide a lot of evidence that requires a lot of data collection, very well designed, very well controlled trials. And that's why I've sort of gone into the education route rather than the treatment route. It's easier to get into. From the point of view of education, we know that surgical rehearsal reduces operative times. Whether or not that produces useful clinical outcomes, that's hard to prove in a research setting. But, you know, the way I think of it is, if I've rehearsed a very uncommon operation, let's say a perforated duodenal ulcer, and I've got the confidence to do it quicker and do it minimally invasive rather than open, I'm sure Joe would appreciate that when he's anesthetizing a patient, that I do it a lot quicker in a very sick patient, and in a less invasive way. So it's very hard to prove these benefits in research trials, but I think it does make a difference for the patients. The problem is when it comes to monetization, you need evidence of benefit, but I believe in the benefits of this technology. Just proving it can be very difficult.
Yes, and of course it's easy to develop something on a small scale and get it in front of other people and see what I think, and okay, this seems promising, but that's like a very long step away from like a full-fledged application that you can actually deploy. And then also proving that it works, kind of the efficacy and kind of if you show it to people and to your friends and family, they will also be more optimistic. Or that's what people say in game development also. Just find people that are not related to test it, and they will tell you if it's not good. So I definitely want to go a little bit further into this topic. Like this is a thing we see a lot. Like also as a prototyping company, we're coming in from the beginning of a project, and then our clients use the prototypes to kind of raise funds, or they develop the idea, or they maybe prove it out for our academic clients. But then there seems to be a gap. So it's like you have somebody that can initiate project, and you even see it in companies. Like there's people that are good at starting new companies, and then they have to hand it over to somebody else, and then they have more professional CEO that will do it in a structured way and kind of grow it. So so that's kind of the two phases, right? Like you have the ideation and the conception, and then you have your first baby, and then it needs to grow up, and there seems to be like a kind of a barrier that it makes it a bit difficult to really get it to grow up from it's a lab environment, so to speak, into the world, and really scale it as a business. So yeah,
I think the barrier that I've had that both Bernard and Joe can answer is sort of talent acquisition. How do you find the right talent to work with you and believe in your vision? That's something very difficult, and that's something required to scale. Yeah.
Yes,
I mean,
for sure.
Yeah. I mean, I could speak to that, and it's very succinct in that I think it's the same way that change is achieved in healthcare, which is through painstaking, steady pressure and persistence. Because, you know, it's healthcare is a stalwart space. Things move slow. We've kind of already talked about that. And I think consistency and steady pressure, and, you know, in the case of finding talent, that might mean just persistently working with people until you find somebody or multiple people with, you know, the right skills and the right chemistry with your existing team.
So after the development, I mean, so there's a development part, but also bringing it to the market. So, and I see a question in the chat also, somebody asking, Robert Connor asking if for us to touch upon the different XR business models and pricing. And so what is your approach to that, Joe? Like bringing it to the market and like maybe some of the challenges as well, like because you can develop something, but you still have to be able to sell it. And I think that's definitely a challenge. I mean, people need to warm up to the technology, even though they've heard of it. It's been there for a little while now, but tell us a bit more.
Yeah, so the overwhelming majority of business models that are out there are software subscription type models. And I think that is correct for a variety of reasons. I think that our space is growing. I think that there's clearly a budding industry in XR for healthcare in particular. I think that will be a defined space in the sense of what business people talk about. But all of that in mind, I think, you know, it's really something that's fundamentally important to keep in mind that the actual space, right? I've seen it kind of go through the hype cycle like twice now. In early, I think it's 2015, I'm guessing, but 2015-ish, when the modern sort of consumer accessible virtual reality headset came out. And the years that followed, you know, 16 and 17, there was a slew of companies that went out and, you know, got venture capital, blah, blah, blah. And, you know, basically, you know, and some of them are still doing great today, but many of them have I think, went belly up. And I think a lot of that has to do with just kind of inflated expectations at the rate of acceleration that was going to happen. I think that people always tend to overestimate what's going to happen in 2 years and, you know, underestimate what's going to happen in 10. And so I'm appreciating slow and steady growth. I think eventually it really will take off. What I've noticed in the past year or so is broader understanding, even amongst, you know, like old timer providers that are, you know, even in their 70s, like within the past year, coming up to me and saying that they've, you know, heard about this and asking questions. And these are not, you know, people that have their fingers on the pulse of technology within healthcare. So I think that's a really positive signal. And as we've kind of alluded to before, there is a lag between when that sort of greater awareness occurs and when, you know, we see it really in a widespread fashion. But it's clearly getting there. And I think, you know, anyone who's in the space doing these sorts of things would probably say the same.
So Omar, talking about the commercial side as well, like you mentioned like, yeah, you do it for passion. This is kind of your primary motivation, which is very beautiful and kind of really gives you a real, yeah, kind of stimulates you to go in a certain direction.
Yeah.
But I do also see the simulation seems to be pretty strong. Like, I mean,
Yeah.
We've also looked into different things, and we've dabbled a little bit in like some smaller prototypes
Yeah.
for surgical simulation, but not on three-dimensional shape. So I do appreciate the kind of the complexity of this.
Yeah.
And so have you thought about kind of turning that into a commercial package or something? Like I definitely see, like, for the development community, this would be pretty cool asset to be able to work with, or what, any thoughts on or ideas that are in your mind to commercialize this?
So some of the thoughts were going down the research route. I was thinking of doing sort of a research degree, developing this further as maybe a PhD, but then I realized that I enjoy what I do as a surgeon. Spending time away from that will attenuate my skills. I don't want to be an academic, and I don't want other people taking away the intellectual property. So that's been shelved, and getting funding for research is very hard. The commercial route, like I said, to develop this into a full viable product, you need an army of people, and I'm not brave enough or skilled enough to risk my own capital, gather the talent, etc. So my planned route is to contact existing companies and see if I can contribute both my technical and surgical expertise. And some of the responses have been quite interesting. They're being offered full-time engineering jobs, which sort of defeats the point of what I'm bringing to the table. Okay, I've got a nice technology, but I'm still my unique point is being a surgeon. I don't want the engineering job. So ultimately, it's the companies need to maybe think about cross-discipline work and how they can turn that into an official role, because I find there's still a big divide between a expert advisor that gives very fleeting advice in a brainstorming meeting and that's it, or someone that's very involved in development but is not losing their clinical duties. And I think Joe managed to balance that because he's in charge of the company. But if I'm working for someone else, then you sort of go by their rules, and that's what's making it difficult. So my aim is to contribute to someone that's got the talent, the manpower, the capital, and see the product flourish, and that would be a benefit to both me and the company. And I've got a few interviews coming up, so we'll see what happens.
That sounds great, and I do see some people in the chat. I don't know for which purpose or for the specific purposes, I mean, but there's some people introducing themselves, so it might be interesting to kind of take a look at that as well. So we'll have to round up to our last question. I haven't really thought of a last question. But I think it was a beautiful journey, like from the conceptualization through some of the challenges in development, testing, as well as commercialization challenges, and kind of your ongoing work in that. So that was really very fascinating to be able to follow. Maybe any last words? Yeah, any take-home points?
Yeah. So basically, my take-home points for aspiring sort of physicians wanting to get into this. Can you see my screen?
Yes, now we can see your screen.
Yeah, is it the slide?
Yes, take-home points for doctors. Yes.
Yeah. So basically, my advice is don't reinvent the wheel. Identify the right hardware platform, which is what Joe did in the very first bit in his planning phase, and then find the tools and engines you need to learn. Learn the fundamentals of the programming languages, but don't try and aim to master them before you start prototyping. Start playing around. You're not going to become an expert on C# or Python if you're a full-time physician, but don't be afraid to play and experiment. When it comes to debugging the code, don't do it haphazardly. Debug your code how you would diagnose a patient. Form a differential diagnosis and test your hypothesis with the debugger. Use logs, memory views, and breakpoints, just how we use blood tests, radiology investigations, functional tests to assess our patients. And finally, I think the way you should learn is you should use problem-based learning. Come up with the problems and focus your learning there. Don't try and master the complete computer science course from start to finish.
Yeah,
that will keep you motivated.
Yeah, it's definitely an advice I give our programmers also as they are working on prototypes. Like sometimes you see an obstacle, you don't always have to climb over that obstacle. You can just go around it in some cases, or and achieve the same result. So it's like, of course, there's pride in, okay, I see this challenge, I want to figure it out. But at the same time, sometimes you can just find another way around it. And so yeah, that's interesting also to see the metaphors. So we're kind of wrapping up the kind of this panel discussion part of it, but we do have some questions that come up in the chat. So I think we I think we all have maybe still a little bit of time to answer a few of the questions. So yeah, people feel free to go if you need to go anywhere. So we'll stick around to answer a few questions. So some questions from the chat and from in the audience. I don't know if this one was answered, but early question that came up was for Joe, are the Waya Health goggles considered a medical device by the FDA?
So the headset itself is not whether something is considered in the eyes of the FDA. My understanding is that anything that it depends on how you're marketing it. It depends on what you're claiming from it. So I can, take a coffee cup and say, it's used for anesthesia if you bang yourself over the head with it. Well, then I would have to go through, a very rigorous FDA approvals process. So it's about the claims you're making. That's fundamentally. So I think that's just a correction in terms of what might be implied by the question. So that is really a key thing is, in the eyes of the FDA, it's what you're claiming something does. And so, namely, that's how you're marketing it and what you're saying something does. And so that's I think the key point there. And in terms of just to the previous question, in terms of what are the take-home messages for anyone who might be a provider who's thinking about coding or learning coding or already maybe has gotten started. I think really fundamentally what attracted me to it is because is the fact that within healthcare, there's a million reasons to say no. If you're looking to not help somebody for regulatory reasons, for a zillion different reasons, it's easy to say no. And this is something where you as the provider can be empowered to work on reasons or work on solutions that take away reasons to say no. And that to me is a beautiful thing. And that is in a very fundamental context that's not germane to any particular indication or not germane to any particular use case. But that really is where the magic lies, in my opinion. And I completely agree with all of Omar's points in terms of more of the detailed aspects of, how to get started and how to do it efficiently.
Okay, we have another question which came in earlier, which I believe was for Omar. And I don't fully understand the terminology in the question, but I'll just read it verbatim. How are you assessing tactile surgical skills relative to novice versus expert development? For example, application on a PGY1 to PGY4. I don't know what that is. Have you applied across residencies to assess their competencies? So I guess it's about the testing of your.
Yeah. So I think using simulation as an assessment tool is a minefield in itself. And some people try and use surrogate markers of surgical proficiency, like how long it took, how efficient your instruments are. And I'm sure Joe has watched many surgeries and can judge surgeons on other parameters completely. So I think trying to fit surgical quality based on very rigid subjective parameters is nice on paper, but it doesn't really translate to reality. And I think my ideal assessment method would be that you would have an expert surgeon review the video of the virtual operation, and then you'd have a panel that would assess it on some objective criteria, but also things like sort of their safety, their understanding of the anatomy, etc. I think these very objective measures that people get obsessed about, like how many centimeters your instrument moved, are not very valid assessment markers.
Yeah, Omar, I'm curious about your thoughts on just the propensity to be able to compare, you know, me today to me 3 months from now, you know, and as opposed to pure comparison, because, you know, I think that's because simulation provides that safe context in which you can do as many iterations as you want.
Yeah. So I guess if you have a very high fidelity simulation, then you can go beyond the basic instrument measurements. You can maybe measure the blood loss, something that's more clinically relevant. If you're simulating soft tissue behavior, you can simulate how much tissue damage was caused, how much tearing was caused, how much tension was applied, because ultimately in our field of work, if you're not applying the correct tension, you're inefficient. So it's sort of looking like, I'm sure you've seen attendings teach their residents, and you've heard the things that they would berate them about, and I think those are more valid comments to make than how many centimeters your instrument moved.
Right.
So it's trying to translate an expert mentor's advice or feedback, and I don't think it replaces the trainer. I think it's just a safe space, a sandbox to train on.
Right.
So
Which
this
is
is
similar to flight simulation. It's sort of they're still assessed by external assessors. They're not assessed on the numbers.
Right. Your first go at it is in a simulator and not on a patient, which is in and of itself an attractive thing.
Yeah.
So there's actually an interesting thing. I mean, we did as I mentioned, we did like a small project with surgical simulation where we basically it was for laparoscopic surgery, kind of to enhance what they normally do with telestration in terms of marking things on the image of an ongoing surgery. We did like some simulation where it was like the video was actually projected onto a kind of elastic surface and you could cut in that. But then one of the things we were discussing with this client is that he mentioned like, okay, if you're doing actual surgery laparoscopically, there's an aspect of haptic feedback in terms of what do you feel, and adding some of that in the virtual simulation seemed kind of like I don't know, maybe a little bit of a holy grail, as in that it would really be something interesting. Like, what is your view on that? Is that something you've been experimenting with? Like, because in VR you can just move your hand anywhere, and regardless of actual objects in the real world. So how do you...
For the laparoscopic surgery, I've simulated the 5 degrees of motion limitation with 3D printed accessories to anchor the controllers. Sort of active haptic feedback that's motorized, I haven't done, but other people have done. And I think ultimately it's useful in the early learning curve, but as a surgeon, I can train people without even being scrubbed in. I don't need to feel what they're feeling to tell them what they're doing wrong. We develop a lot of cues, and robotic surgeons, they get no haptic feedback, and they're still operating safely. They're not tearing the tissue. So I think it's very useful in the early learning curve where you haven't developed depth perception, and you're sort of moving the instruments and you're just orienting yourself in 3D space. But later on in the learning curve, I don't feel haptic feedback is essential. It's nice. It definitely elevates the experience. And I think, like you said, having it definitely adds to the experience, but getting it right is very hard. And I think it shouldn't be an obstacle, because I'd rather have an engaging simulation without haptic feedback than a sugar cube stacking simulation with haptic feedback.
So basically, you're like confining the physical movement of the controllers using some 3D printed accessories, and that way they stay within a realistic
the confines,
range. Okay, that is a very interesting approach, and sometimes a simple idea can go really far that way. So that and avoiding the obstacle basically by not going there with your hands. There was a pretty interesting question which makes me think of maybe some Black Mirror episodes where things go wrong with technologies and people cannot take off their headset anymore. Maybe, I don't know if we're evolving into a world like that. This is not a science fiction show, but somebody asked the question, what is the longest period of time a patient has spent without removing the headset in any of your work?
So I can field that. We've put a limit on it from very early, from inception. So we pretty much limit any session to 40 minutes. That has to do with a couple of things. Number one is not causing significant interruptions with regards to what providers have to do. The other thing is, particularly the first couple times folks use virtual reality, there is this sense of, if you keep the headset on for a long period of time, there is almost like a dissociative phenomena that's very brief, but it is there after you take off the headset, where, you know, for a half second, you're like, wait, is this the real table in front of me, or is this the virtual table? And, you know, we don't want to worsen any pathology or anything like that. And so we have kind of placed a hard limit on our session length of 40 minutes from day one. And we're really not going to change that until there's really strong evidence to, you know, indicate that doing anything longer is beneficial for a certain thing. So, and that's a great question.
And would you say the 40 minutes is just like gut feeling kind of, oh yeah, I think based on your own experience, like 40 minutes seems like a good number, or is there any, or was that based on anything specific? Or
yeah, so it's a combination of things. When we first kind of instituted that, we looked into literature, and you know, the things that were kind of put out there or published, let's say, in a broader sense, were, you know, edge case or extreme examples of, you know, somebody stays in there for hours. And so we erred on the side of being conservative. And then we also, you know, through, and this again, this is maybe 5 years ago, through just iterative testing amongst ourselves, kind of came to that being the longer session length limit. Most people, frankly, don't get to that limit, to be clear. So it's not really an issue. And a lot of it has to do with two things. One is just how long people want to use it. And, you know, if your family's coming in the room or whatever, or, you know, you want to interact with people in the real world, just like everyone else. And so that's a practical thing. And then the other piece is that the implementations we're doing, certainly on the assessment side, or even in terms of like a ecological treatment construct, they're very efficient. And, you know, you can, because of the fact that it's a three-dimensional medium, and, you know, a picture's worth 1,000 words and a video's worth whatever, keeping all of that in mind, you can do a lot. You can cover a lot of ground in a very short period of time. And that, you know, is also a fundamental underpinning of, I think, what is the attractive clinical case, as well as the attractive business case, and how you can leverage extended reality in that fashion.
Is your longest use case sort of the local anesthesia procedures? Do you find?
Yeah, so intra-procedural probably is, now, of course, as you know, it's surgeon dependent, right?
Yeah.
So, you know, I've worked with surgeons that do carpal tunnels in 12 minutes, start to finish. I've worked with surgeons that do carpal tunnels in about 90 minutes. So, you know, granted, they're trying
take out
to
someone's colon in that time.
Yeah, well, yeah. Well, those are typically like the fancy endoscopic approach, but either way, I mean, there's a huge degree of variation.
And battery life as well.
Yeah, so we have a select sort of list that we provide customers, clients with, that are kind of the procedure types that fit within this realm. And we, even despite that, we have not exceeded 40 minutes to my knowledge. And so, you know, and we have safeguards to prevent against anything that we've identified. We identify something as an issue, we develop a safeguard to address it. So that instance is the session cuts off at 40 minutes. It's really, you know, or whatever we set it for. So that's really, you know, a good example of, you know, taking that approach from the design phase and applying both our clinical knowledge as well as, development skills to achieve the result we want.
Yeah, it's almost like a pharmaceutical approach to sort of adverse events handling.
Right, and iterative improvement. Yeah,
Yeah.
exactly.
Okay, well, thank you both. It was very interesting, also for myself, and I hope for the audience as well, of course. It was a real pleasure. And I see I'm going to hand the mic back to Steve.
Yeah, well, thank you. This was absolutely fantastic. This far exceeded my expectations, and the depth of the answers here were really fabulous. I will send the chats off to you folks in case you want to follow up with anyone. On the time in VR, I interviewed one of Peter Jackson's, the director's lead technologists, and he had two things to say. He said, "If you really could be Spider-Man, wouldn't you do it every day?" And the second one was, if the game where they drive around and rob people, I forget what, something auto.
GTA, Grand Theft Auto.
Yeah, Grand Theft Auto.
Yes.
He said, if Grand Theft Auto becomes absolutely realistic, can people drive after doing 2 hours of it? Which is kind of interesting and speaks to the power of it. I just want to bring up a screen so people know how to reach me, and I'll also talk about our next talk, which is on the 22nd of February. We have Thomas Wolpers from the German Center of Neurodegenerative Diseases, joined by Philip Stepnicka, talking about the immersive VR for treating deficits with social interactions. Dr. Wolpers has a few decades of research, and he's approaching 10,000 citations. He's a really interesting person on this topic. And moderating, we have Margot Paul, who is a clinical psychology postdoctoral fellow at Stanford, and runs the XR program within the psychiatry department, which is really quite interesting. So I'm looking forward to that talk, and I want to thank the audience. I want to thank Omar and Joe for being the unicorns that they are, and having the chance to meet you both. Very hard to find you guys, because the competency of your STEM education makes you so self-reliant that you don't show up at the user group meetings. You just fix the problem yourself. And Bernard, you were the perfect moderator for it, because of all your experience in helping people figure out what they wanted to build. So thank you.